I wanted to record this short video for you to give you a concrete example, step by step, of how to write the equation of a parabola given certain information, and also how to graph the equation of the parabola. This one is just a basic example where you're already given the equation and you will be completing the square and identifying the important characteristics of the parabola and then using those characteristics to graph. So we want to find the vertex, focus, and directrix of the parabola given by the following equation: y squared plus 2y plus 12x minus 23 equals 0. Then we're going to graph the parabola. We will begin by converting the equation to standard form, and since y is the variable that's being squared, we want to get all of the y terms on the left-hand side. So that means we will be taking 12x and 23 to the other side using inverse operations. And so we have y squared plus 2y equals negative 12x plus 23. And remember, the goal is to complete the square using y squared plus 2y. We want to create a perfect square trinomial. And so y squared plus 2y, if we divide the middle term by 2, that gives us 1 for the coefficient, and then if we square that, we still get 1. So that means that we're adding 1 to the left-hand side in order to complete the square. Keeping in mind this is an equation, whatever we do on the right-hand side, or on the left-hand side in this case, we also have to do on the right-hand side. So this becomes minus 12x plus 23 plus 1. And let's do that a little better. We can make that cleaner. So negative 12x plus 23 plus 1. And again, this plus 1 has to do with completing the square and recognizing that the equation has to remain in balance. So if I were to now factor this perfect square trinomial, this becomes y plus 1 squared equals negative 12x plus 24. Now we're almost there. Remember that our standard form is, I'm going to write it down here in the bottom left-hand corner, y minus k squared equals 4p times x minus h. And so we just have a little bit more to do to get it in that format. There we go. And that is to factor out a common factor from the right-hand side. And so this becomes y plus 1 squared equals, the common factor between negative 12x and 24 is negative 12. We want our leading coefficient on the variable to be positive. So this becomes negative 12 times x minus 2. And then once in that format, we have to deal with this left-hand side as it's y plus 1, and we're used to a y minus k. So we can recognize that that's the same as y minus negative 1 squared in terms of helping us recognize what the vertex of the equation is, equals negative 12 times the quantity of x minus 2. Now in this format, we should be able to recognize the vertex. Remember that the vertex comes in the order of hk, where h is always with the x variable and k is always with the y variable. So our vertex in this case is 2, negative 1. Next, we need to identify our distance p, which is the same distance from the vertex to the focus as it is from the vertex to the directrix. So 4p in this case is negative 12, which means that p is negative 3. Now there are some things we need to also recognize about this parabola. Being that y is the variable that was squared, that tells us that this is a parabola that has a horizontal orientation. Because our p is negative, that tells us that this is a parabola that will open to the left. So just as a quick sketch, we have something that's horizontal that will open to the left. Remember, the focus is always inside, if you want to think of it that way, the parabola. And the directrix is always outside. And in this case, the directrix is going to be perpendicular to the axis of symmetry. We have a horizontal axis of symmetry. And so our directrix is going to be vertical in that case. And so that gives us an idea of how to use this P to find what we need to find in terms of the focus and the directrix. So let's take a look. Now, because the axis of symmetry is horizontal, that means that the focus will have the same y coordinate. And so we know that, as the vertex it is. So we know that the focus has a y coordinate of -1. And keep in mind that the vertex was 2, -1. Now, to find the x coordinate of the focus, we just need to know that if the vertex is at 2, -1, that the focus is 3 units to the left of that. And so if I'm at +2 on the x-axis and I go 3 units to the left, at what number do I arrive? Hopefully, you noted that we would arrive at -1. So your focus is the point that has an address of -1, -1 on the coordinate system. Your directrix is a vertical line, which means it's going to have an equation with x equals. That number is going to be 3 units away from the vertex in the opposite direction from the focus. And so it's going to have, again, the same y coordinate on the axis of symmetry, but we're concerned about what that x value might be. So if I'm at 2, -1 for my vertex and I go 3 units to the right, then that leaves me at x equals 5. And so my directrix is the line that is formed by the equation x equals 5. So we've done part 1, which is to identify the vertex, focus, and directrix of this parabola. The next thing we need to do is graph it. You have 3 parts that will help you graph. You only need a couple more points to help you out with this. And so my way of doing it is just to try to be kind of intuitive to get some really pretty numbers out of this equation. So let's go back to our equation, the original, which was y plus 1 squared equals -12 times x minus 2. If we are very careful and we choose a value of x that will make the right hand side a perfect square, then taking the square root of both sides will give us some really wonderful numbers to work with. So 12 times what number will give me a perfect square? Well, 12 times 1 is 12. That's not a perfect square. 12 times 2 is 24. That's not a perfect square. 12 times 3 is 36. 36 is a perfect square. So if I let x equal -1, then this becomes y plus 1 squared equals -12 times -3, or y plus 1 squared equals 36. So now when I solve this, I have y plus 1 equals plus or minus the square root of 36, which means y plus 1 is going to equal 6, or y plus 1 will equal -6. In the case of the left-hand side, I'll have that y equals 5, and on the right-hand side, I'll have y equals -7. And so that gives me a couple of ordered pairs to work with as I prepare to graph this parabola. Okay, so now we have a vertex of 2, -1. We have a focus of -1, -1. A directrix defined by the line x equals 5. We were also able to find 2 ordered pairs, -1, 5, and -1, -7, both which lie on the parabola. We know that because of the y squared, that this parabola is oriented in a horizontal direction, and because of P being negative, that this parabola opens to the left. So let's get some of that information on the graph. But first we're going to label our axes. There's our x-axis, our y-axis. We're going to label our scales. 0 for the origin, 2, 4, 6 in the positive x direction, 2, 4, 6 in the positive y direction. And then I'll start to plot some of these. The focus at -1. -1 is here. Put this in pink since it's not really part of the parabola itself. The directrix is an imaginary line here at x equals 5. Again, not really part of the graph, but helps us define the parabola itself. We know the parabola opens to the left. We have a vertex at 2, -1. We have a focus. I'm sorry, we already did the focus. We have an ordered pair of -1, 5, and another ordered pair of -1, -7. 1, 2, 3, 4, 5, 6, 7, which is about there. And so we'll just connect these blue points with a smooth curve, as smooth as we can. Kind of like that. Mine is not so smooth, but I think you get the idea here. Clean that one up a little bit. And so our parabola will kind of look like this. I'll also put the axis of symmetry on here, which is a horizontal line that's going to pass through both the focus and the directrix. So the axis of symmetry is the line y equals -1. And so there you have your parabola. Research lattice rectum, which is another part of the parabola. Once you understand the relationship between vertex, focus, directrix, the distance P, the lattice rectum, you can write the equation for any parabola and you can graph any parabola. If you have any questions about what you see here, make sure that you speak up on Edmodo. I'll be checking in over the weekend as I can, and I will chat with you guys at some point next week. Have a great weekend.